Okay, so making our way through the FMT package, the next thing we're going to look at is the two procedures that are called assert F and ensure F. So if we go into the FMT package and we search for just assert and ensure do very similar things. We can see here that we have the definition of what assert does. It is a runtime assertion with a formatted message. Now, if we go into the built-in package, we see that there already exist an ensure and an assert. The formatted version of ensure that we find on assert that we find inside of the FMT package simply allow us to add a formatted string like many of the other print procedures, but they essentially just do what this does here, just with a nicer string message. Now we'll actually have a look at what it says. It says it evaluates a condition and panics the program if the condition is false. This uses the context.assertion value procedure to assert. This routine ignores Odin disable assert and always executes. Now that's an important distinction. So ensure will ignore this and always execute. And if we go over here, the assert looks pretty much identical, has more or less the same description, but this routine will be ignored when Odin disable assert is true. So inserts and ensures are basically like if statements where if the condition is false, instead of not executing some code within their body, they will simply crash your program. They will break it. And there might be a few reasons you want this to happen. It could be that you're just debugging. So you get to a certain bit, you're running into an issue. You try to assert something to be true. If it's false, it breaks, and you can kind of narrow it down and go, that is got to be at least something what is causing my stuff to break. Or it might be that you actually want your program to crash rather than continue because its continued execution would be a lot worse than it crashing. For example, maybe you have some type of machine needs a configuration file load into it for it to operate properly. For some reason, configuration file isn't there. Instead of having your machine continue doing whatever its function might be, you might consider instead of you continuing to work without your configuration file, it's deemed too dangerous, you might break yourself. So just crash the program, stop everything from working. And the assert can be used for the debugging quite nicely. As it says, we can disable this when we set this Odin.disable assert to be true. And we can see how we can find this Odin.disable. It's actually a compiler flag. I'll just go out of this example here, and I was to do Odin run and then just the help flag. Scroll up here. There is a flag called disable assert. We can see here, disable. Disables the code generation for the built-in runtime assert procedure and defines the global constant Odin disable assert to be true. So if we are using asserts, we can use them for debugging purposes. We can fill our code loaded with asserts, and then when it finally comes to generating the finished product, the thing where we're sure all these asserts are always going to be true, instead of having to go through and delete them all, we can actually leave them there, and we can call this disable assert when we build the application, when we build the executable, and the compiler will simply see the asserts and ignore them. It will pretend they're not there and keep executing them. That way we have a version of the program where the asserts are being taken out of the end executable, but we also have the source code files that still have the asserts inside of them for future development. And then we have the ensures. The ensures would be used more on the lines of when you're using a machine or something. When you have something where you absolutely want your program just to fail, if something is found to be false, like that configuration example. So you can have your ensures in there that will be in there no matter what. This little flag here will not take out the ensures. They will always be in the code, and they will be ready to basically break your program if something has gone wrong, if it is deemed that breaking the program is better than it continuing on with its execution. Because if a file isn't loaded properly inside of a program, you might not know, but it won't actually break the program. You might get an error message returned. You can get an error type in Odin return saying, hey, my error, your file didn't load, whatever, will continue. But it'll be better if it breaks in some cases. And if you go into the core_built-in.odin file found in the base runtime directory, I think it is, you can actually see the implementation of assert and ensure. We have assert up top and we have ensure down below. We can see that they're both built-in types. I'm assuming this is what this tag stands for. If one of these procedures is tagged with the built-in above it, I'm making the guess, I've not looked into this, that this just means make this procedure just globally available everywhere in the program without having to explicitly import any type of package. That's what I believe this built in to be. Again, that's more or less an educated guess. But we can see here above the assert, we do have the disable equals Odin disable assert, which is further, evidence and proof that the documentation is correct. If this Odin disable assert flag is set to true, then the assert itself, this procedure here, it will basically comment it out of the code. It won't have anything generated for it in the end binary file. But below, ensure doesn't, which means that even if this is set to true, the ensure will stick around, it will be persistent. Now, interesting enough, I was looking into these, and there's some stuff I've never actually seen before. This little note from Bill, this is wrapped in a procedure call to improve performance to make the CPU not execute speculatively. I struggle with that word so much when I'm talking. Make it about an order of magnitude faster. Honestly, no idea how this works or why it works, but that's interesting to know. I'm going to add that to a list and look into it. See if I can figure out why. Why does this make it faster? Also, don't know what this cold tag is. So there's a few extra things in there for my own learning on the side. Now we're actually going to, just a demonstration of showing this work. So I got a small little file here. Very small demonstration. We're going to pretend that the program is doing something at the start. We're going to assert something to be true. And then we're going to continue on. So if I was to just quickly compile this with Odin run dot, exactly what you'd expect. The program just works. Nothing special. The strings print out and the program finishes. But what happens if we don't run the program again? If we go into the source code and then we decide to make this true, because 1 is not equal to true. So this is going to cause this assert to fail. And we'll run this. And the top thing happens, the very first one, because program is doing so, but we don't get to the end. Instead, what we have is a runtime assertion. 1 is equal to 2, so it fails. Illegal instruction, code dumped, Odin. So it's created a dump file, which you could then find and read to help you debug. Another thing that we can do with the plain assert is if we go into here, we look at the documentation again, we'll see that they do allow a string to be inputted inside of them. So if you wanted to just have a simple output message to this to kind of explain why, something did not work. That is a terrible error message. But if we then run this again, we will see that we get the runtime assertion. Instead of saying that 1 is equal to 2, so this is why it failed, we can now instead get the string, something did not work. And then finally, the reason I came across this in the first place is because we've been looking at the FMT package and we saw that there is a formatted version and it works pretty much how you would expect. So FMT assert F, this now turns a string into a formatted string. So if we had some other extra information, like trying to figure out why this assertion might fail, we might have a few extra values that we want to throw in there. So we'll just quickly create a formatted string. And we'll just put in some values there. For whatever reason, these could be the error values. And then we try to do it again. This assertion is going to break and expected one expression. Did I break something? Hello. Expected a got an integer. Oh, How have I broke this? FMT assert you there. Did not work. Value, comma. Oh, that's why I missed a comma up. Haha. Okay, now if we run it, we see that the runtime assertion fails, but this time we have a formatted string. So that is the use case of the formatted version of assert. Now, what I was saying in the beginning, let's assume that we are confident whatever bool we pass in here is always going to be true at this point. We've tested our program. It's good to go. We want to make a compiled version of this, but we don't want these lines of code to be added into the end executable file because that's just going to be bloat. It's not needed. It doesn't need to be checked. It's going to work. This is just for our debugging purposes when we're actually building the application. What we can do is we do run, and then we're going to make this file, but we add in the disable assert. And even though that assert should fail, it is 1 is equal to 2, which is false. We can see by adding in this compiler flag, the Odin compiler, just when program is running, found the assert, essentially commented out, does nothing, and then just continues on with the rest of the program. But as we saw in the documentation and in other places, if this is an ensure, so this is basically a type of if statement where we want the program to crash. If this is found to be false, we want the program to crash. We don't want the continuation to happen. This isn't debugging. This is, we found a major error, just please crash the program and dump your error message. You can try and figure out what went wrong. Even though this disable assert flag is set to be true, we can see here that ensure is not declared by FMT, which is very true because it is the ensure formatted version that is declared by FMT. And now we get the error that we were expecting. Program unsatisfied ensure, something did not work, and there's our values. So that is the difference between an assert and an ensure. They are both essentially if statements, as I've mentioned quite a few times already. And we basically want them when we just want our program to crash, should something be false. Yeah, and that's my little talk about asserts and ensures. I'm getting pretty close to the end of what I want to look at in this format package. I'm probably going to have a look at a few more. In the new year, I'm going to start developing something, actually try to make an actual, just a more larger project for anybody who's listening this far into the video. And other than maybe the string print functions down here, I think there's not much more I want to look into myself in this package. There is this wprint procedures down here, which I've not looked into. They use something that is in the IO. So IO in this case, it'll be the it'll be this one here. So yeah, maybe I'll go on to look into a few more before I move on. But other than that, I'm going to move on to the next one, and I'll see you later.